Hello and welcome to this video about an introduction to functions. The learning target for this lesson is defining and going over functions and function vocabulary. So first of all, I want to talk about the big picture. And so one thing I love to kind of say is that half of algebra is x plus 1 equals 2. When we're talking about functions, we're still dealing with x plus 1 equals 2. But here's the difference. Instead of saying x plus 1 equals 2, we say x plus 1 equals y. And so what we're doing is we're introducing a second variable into the mix. And this obviously changes a few things, but a lot of this a lot of the same concepts with equations and solving are still present and still are still the same with functions. But let's just know that we're now dealing with x plus 1 is equal to y. Another way to kind of look at it, and sometimes I kind of adjust the equation a little bit, x plus y is equal to 4. What are some, let me get rid of that right there. Let me clean that up. Here we go. X plus y equals 4. What are some sets of x's and y's that we can plug in here that make this true? So it could be something like 1 and 3, 3 and 1, 2 and 2, and we can come up with a whole variety of these things. And this right here is where we start to get into functions. Functions are a grouping of these possible solutions. So now let's talk about some of the vocab. First thing we have to define is actually a different word altogether, and that is relation. Now a relation is a collection of ordered pairs, ordered pairs that relate inputs and outputs. Now, obviously, I don't know if I made things any clearer because I've now introduced a couple other words here. But essentially, a relation is just a set of x, y points. And that's what I mean by inputs and outputs. So an input has two meanings that we're going to go with. One, it's the x variable, but it is also the independent variable. And we'll talk about that in a minute here. Then we have output. That's not how you spell output. Let's try that again. Output, which is the y variable, and that is the dependent variable as well. Dependent. Perfect. Cool. And again, we'll talk about what do I mean by independent and dependent in a minute here. Now, relations are everything. Functions are a special kind of relation. And so now we can talk about how we define functions. Functions are special relations where each input goes to only one output. And so that is what a function is. Now, functions can be displayed in several different ways. We have mappings / tables, where we either go with something like I and O for input output, or we have an X and a Y. Sometimes we use ovals, and then same thing, I and O, and then we kind of like try to connect some dots or something like that. You'll see in a minute. We have equations, which we'll talk about later, but essentially an equation could be something like x plus y equals 4. And finally, we have graphs. And so graphs could either be something like that, or it could be a set of points on the graph. And so that's how we can view these functions. But now I want to talk more about this whole input-output thing, because I don't know if you remember, but we had an analogy. And I made this limo analogy where we have, when we're talking about variables, I know not best limo. Let me try again. Okay, I drew them a little better this time. All right, so I talked about how like with an award ceremony, and there's like a red carpet beforehand. At the beginning, before the ceremony starts, you have a limo anyone can come out of it. And that was analogous to where we had something like x plus 2. We could plug whatever we wanted into x. Well, if we now make this y equals x plus 2, we have, we have the after the award show. And the idea with after the award show is that not just anyone can go into there, but you have to have something very specific in there. So you have to, there's only a particular thing that will work. So something very specific works for that. And so what that means is that if we plug something into x, y is going to relate to that. Y depends on x. And so let's say I let x equal 3. Well, if that's the case, I'll get y equals 3 plus 2, which means that y equals 5. 5 was, the y variable was dependent upon what x is. And if I change x, y is going to change. And so it's very similar to our limo analogy where before, if we have just x plus 2, we can plug whatever we want. Anyone can come out of that limo. But after the award show, you have to go back to your actual limo. You can't, not anyone can come out of it or go into it, but you have to find your actual limo. Okay, and so what this means is that when we're looking at independent-dependent situations, is we need to think, what's the driving force here? Or perhaps what might be easier is ask yourself, what relies, oops, that's not how you spell relies, on something else? Now, more often than not, the independent variable is x, and it is also time. Especially if we're looking at word problems, time tends to be the thing that is always independent, and then something else relies on it. But if you're trying to like kind of sort through what is it that relies on something else, you need to, that will help you find the dependent variable. Okay, last thing I want to talk about is this idea, is something a function or a relation? So the way it works is we need to zone in on our inputs. And so here we kind of have like what mapping would look like. And all we're looking for is that each input here goes to only one output. So notice how 2 goes to 13, 4 goes to 10, and 6 goes to 16, and that's it. Since each input very conveniently pairs with only one output, that is a function. Now take a look at number 2. See how 5 here is going to 21 and 20? That's not cool. So what that means is that this is a relation. And then finally, number 3 is kind of a special case. We have 11, 12, and 13, each input going to the same output. It may look like that shouldn't work, but it actually does, because 11 is only going to -3. 12 is only going to -3, and 13 is also only going to -3. So that would be a function. And then, just to kind of show you, another way of writing these is with an XY table. And so it's the same concept. It's just 2, 4, 6, but now maybe we would pair them up. So 13, 10, and 16. Here, with an XY table, it's more apparent that, maybe this one's not a function because we would have 4, 5, 5, 7. And now we're seeing the same X value pop up twice, but it's pairing with something that, or pairing with 2 different things, which would make it not a function and make it a relation. And then finally, the other XY table would look like this, XY, where we have 11, -3, 12, -3, and 13, -3. And here we can kind of see, yeah, this looks much more like a function because things are just going to, or you're seeing one thing in the independent side, the X side, going to something on the Y. And so input outputs, you tend to map them and you draw these lines to connect and to show where they're going to. The tables, you're actually making a list of points that you could then plot on a graph. So this is an introduction to functions. Hopefully you're picking up on some of the vocab. Good luck with your homework or practice, and let me know if you have any questions.